Introduction. Students, look at this polynomial. What can you say about this? This is a polynomial in the variable x of degree. You're right. Similarly, 2y square minus 3y plus 4 is a polynomial in the variable y of degree 2. And 5x cube minus 4x square plus x minus square root 2 is a polynomial in the variable x of degree 3.
Teacher, is this expression a polynomial?
No, none of these expressions is a polynomial. Today we will learn about polynomials in detail. Objectives. At the end of this lesson, you'll be able to explain geometrical meaning of the zeros of a polynomial, explain 3 types of zeros of polynomials, learn relationship between zeros and coefficients of a polynomial, explain division algorithm for polynomials. Definitions. The degree of a polynomial is equal to the degree of the term in the polynomial that has the highest degree. A polynomial of degree 1 is called a linear polynomial. A polynomial of degree 2 is called a quadratic polynomial. A polynomial of degree 3 is called a cubic polynomial. 0 of the polynomial is the solution of the polynomial. Thus, in general, if k is a 0 of px, which is equal to ax plus b, then pk is equal to ak plus b, which equals 0. That is, k is equal to minus b upon a. So the 0 of the linear polynomial ax plus b is minus b upon a, which equals minus constant term upon coefficient of x. Geometrical meaning of the zeros of a polynomial. For a linear polynomial ax plus b, a is not equal to 0. The graph of y is equal to ax plus b is a straight line which intersects the x-axis at exactly one point minus b upon a. Therefore, the linear polynomial ax plus b, a is not equal to 0, has exactly one zero. The polynomial equation y is equal to ax square plus bx plus c is a quadratic equation. The graph of a quadratic equation is a parabolic curve. Geometrical meaning of the zeros of a polynomial 2. The shape of the graph of y is equal to ax square plus bx plus c can have 3 cases. Let's discuss them one by one. Case 1. In this case, the graph cuts x-axis at 2 distinct points a and a bar. So the 2 zeros of the quadratic polynomial ax square plus bx plus c in this case are the x-coordinates of a and a bar. Case 2. In this case, the graph cuts the x-axis at exactly one point, that is, at 2 coincident points. The 2 points a and a bar of case 1 coincide here to become one point a. Case 3. In this case, the graph is either completely above the x-axis or completely below the x-axis. It does not cut the x-axis at any point. The quadratic polynomial ax square plus bx plus c has no zero in this case. Geometrical meaning of the zeros of a cubic polynomial. The polynomial equation y is equal to ax cube plus bx square plus cx plus d is a cubic equation. This is the shape of the graph for a cubic polynomial. Relationship between zeros and coefficients of a polynomial. For a linear polynomial, ax plus b, a is not equal to 0. 0 of ax plus b is minus constant term upon coefficient of x, which equals minus b upon a. For example, 0 plus 2x plus 3 is minus 3 upon 2. For quadratic polynomial ax square plus bx plus c, a is not equal to 0. If alpha, beta are the zeros of ax square plus bx plus c, then sum of zeros, alpha plus beta, which is equal to minus coefficient of x upon coefficient of x square, which equals to minus b upon a, product of zeros, alpha beta is equal to constant term upon coefficient of x square is equal to c upon a. For example, if alpha, beta are the zeros of 2x square plus 3x plus 2, then alpha plus beta, which is equal to minus 3 upon 2, alpha beta is equal to 2 upon 2, which equals 1. For cubic polynomial, if alpha, beta, gamma are the zeros of the cubic polynomial ax cube plus bx square plus cx plus d is equal to 0, then sum of zeros, alpha plus beta plus gamma, which is equal to minus coefficient of x square upon coefficient of x cube, which equals to minus b upon a. Alpha beta plus beta gamma plus alpha gamma, which is equal to coefficient of x upon coefficient of x cube, which equals to c upon a. Product of zeros, alpha beta gamma, is equal to minus constant term upon coefficient of x cube, which equals minus d upon a. For example, if alpha, beta, gamma are the zeros of 4x cube plus 2x square plus 3x plus 1, then alpha plus beta plus gamma is equal to minus 2 upon 4. Alpha beta plus beta gamma plus alpha gamma is equal to 3 upon 4. Alpha beta gamma is equal to minus 1 upon 4. Division algorithm for polynomials. If px and gx are any two polynomials with gx is not equal to 0, then we can find polynomials qx and rx such that px is equal to gx into qx plus rx, where rx is equal to 0 or degree of rx is smaller than degree of gx. Let's divide 5x cube minus x square plus 6 by x minus 4. Let's first get the problem set up. Recall that we need to have terms written down with the exponents in decreasing order, and to make sure we don't make any mistakes, we add in any missing terms with a 0 coefficient. We need to multiply x minus 4 to get the first term in first polynomial. In this case, that is 5x square. So multiply x minus 4 by 5x square and subtract the results from the first polynomial. The new polynomial is called the remainder. We continue the process until the degree of the remainder is less than the degree of the divisor, which is x minus 4 in this case. So, we need to continue until the degree of the remainder is less than 1. The degree of a polynomial is the highest exponent in the polynomial. Also, a constant is thought of as a polynomial of degree 0. Therefore, we will need to continue until we get a constant in this case. Here is the rest of the work for this example. Okay, now that we have got this done, let's remember how we write the actual answer down. The answer is 5x cube minus x square plus 6 whole upon x minus 4 is equal to 5x square plus 19x plus 76 plus 310 whole upon x minus 4. We can verify the answer by using divisor into quotient plus remainder is equal to dividend. If divisor into quotient plus remainder is equal to dividend, then our answer is correct. Example: divide 3x square minus x cube minus 3x plus 5 by x minus 1 minus x2 and verify the division algorithm. Solution. Firstly, we will write both the dividend and divisor in decreasing orders of their degrees. Minus x cube plus 3x square minus 3x plus 5, and divisor is equal to minus x square plus x minus 1. By dividing, we get divisor is equal to minus x square plus x minus 1. Quotient is equal to x minus 2 and remainder is equal to 3. Now to verify, let's see whether divisor into quotient plus remainder is equal to dividend or not. So, divisor into quotient plus remainder is equal to minus x square plus x minus 1 into x minus 2 plus 3 equals minus x cube plus x square minus x plus 2x square minus 2x plus 2 plus 3 equals minus x cube plus 3x square minus 3x plus 5 is equal to dividend, hence verified. Did you know? We have many useful facts about polynomials. They are the friendliest of all forms of mathematical expression since each involves only multiplication and addition operations. The number of real zeros of a polynomial function is never more than the degree of the polynomial. Every polynomial with integer coefficients and constant can be factored to the product of linear or irreducible quadratics in the integers. Summary. Let us summarize what we have learned. Polynomials of degrees 1, 2, and 3 are called linear, quadratic, and cubic polynomials respectively. A quadratic polynomial in x with real coefficients is one of the form ax square plus bx plus c, where a, b, and c are real numbers with a is not equal to 0. The zeros of a polynomial px are precisely the x-coordinates of the points, where the graph of y is equal to px intersects the x-axis. A quadratic polynomial can have at most 2 zeros, and a cubic polynomial can have at most 3 zeros. If alpha and beta are the zeros of the quadratic polynomial ax square plus bx plus c, then alpha plus beta is equal to minus b upon a. Alpha beta is equal to c upon a. If alpha, beta, gamma are the zeros of the cubic polynomial ax cube plus bx square plus cx plus d is equal to 0, then alpha plus beta plus gamma is equal to minus b upon a. Alpha beta plus beta gamma plus gamma alpha is equal to c upon a. Alpha beta gamma is equal to minus d upon a. The division algorithm states that given any polynomial px and any non-zero polynomial gx, there are polynomials qx and rx such that px is equal to gx qx plus rx, where rx is equal to 0 or degree rx is smaller than degree gx.